In a radar system, pulses of energy are transmitted by a powerful ground station. If an aircraft is in the search area, it will reflect some of this energy. The time taken by the pulses to complete their journey is proportional to the range of the target from the transmitter. This information is usually displayed on a Plan Position Indicator, or PPI. Aircraft in the search area appear as blips on the trace. Since each aircraft appears on the trace in the same way, it is necessary to distinguish between friend or foe. This is achieved with an IFF system. Here's how it works. A signal is sent out on the same bearing as the radar pulse to ask a question of the target. If the target is friendly, it will understand the question and can answer it correctly. IFF questions, targets answer. This answer appears as an additional paint adjacent to the echo. We thus have a simple method for identifying the target. To distinguish between several echoes and provide a measure of secrecy, a more highly developed method is required. IFF systems work in conjunction with the radar. The radar transmits and receives on one frequency, but the IFF uses two frequencies. The question is transmitted on one, and the aircraft's reply comes back on the other. One antenna normally handles the radar transmitted pulse and the target echo. Another antenna handles the IFF signals. The radar pulse is passively reflected by the target, while the IFF signals are handled by the target's transponder. The transponder has two main parts, a receiver and a transmitter. The question will only be picked up if the receiver is tuned to the correct frequency. This is the first check. There are three others. The question must be understood and the correct answer determined. Finally, the reply must be transmitted at the correct frequency. This sequence of events is like opening locks with keys. The key is the IFF question. The lock is the decoder in the aircraft's receiver. It is preset to correspond with the key. We thus have two important elements, the lock and the key. If the key is altered, the lock must be changed. In this IFF system, there are three combinations or modes. In mode 1, the pulses are spaced 3 microseconds apart. In mode 2, they are 5 microseconds apart. In mode 3, they are 8 microseconds apart. A mode 2 key will only open a mode 2 lock. Similarly, a mode 3 key will only open a mode 3 lock. Notice, however, that the mode 1 key will open any lock. All these decoder circuits are contained in the aircraft's IFF receiver, but only one is switched into circuit at a time. This is the mode 2 decoder. Let's assume the aircraft's receiver is set to mode 2. If a mode 1 key is sent out, it will be picked up. Internal circuits then trigger the transponder transmitter, which sends back a single pulse. This appears on the PPI adjacent to the echo and identifies the aircraft as friendly. If the aircraft's receiver is set at mode 2 and a mode 2 key is sent out, it will also be picked up. In this case, 2 pulses, spaced 16 microseconds apart, will be sent back. This enables us to identify a specific friendly aircraft. If the receiver is set to mode 3 and a mode 3 key is sent out, a single pulse will be returned. This is normally used to identify the squadron or flight leader. If the aircraft is in distress, the pilot can turn on an emergency decoder, which can be opened by any key, whatever its mode. In this case, 4 pulses, spaced 16 microseconds apart, will be sent back. This tells us that an aircraft is in distress. Let us now consider the relationship of the IFF pulses to the radar pulse. The IFF question is normally transmitted with the radar pulse in such a way that the IFF reply corresponds with the echo. The IFF paint therefore corresponds with the echo. In some instances, the IFF question can be varied relative to the radar pulse. The IFF reply is thus delayed relative to the radar echo. The IFF paints can therefore be made to appear 2 miles beyond the echo, 1 mile beyond it, or coincident with it. Notice one target is offering no responses at all. This target must be intercepted and checked visually. All IFF systems work on these simple principles to provide accurate target identification.